Good morning, Doctor. Today we will do a presentation for group reflection video for engineering seminar subject BMKC 4041. My team member is myself, Teng Wampo, Lara Matthews, Nopati Nazrini, and Wan Anur Roberto Adewoya. Reflection based on 3 seminar talk is top 4 aviation industry, top 5 automotive decision, and top 6 is automation career. The purpose of this reflection is to explain what we learned from the 3 talk and relate them to real engineering practice. Through this talk, we learned that engineering is not only about technical knowledge. Engineer must also understand professional responsibility, safety, decision-making, communication, teamwork, and continuous learning. This reflection also discusses current engineering issues such as digital transformation, cost and time constraint, cybersecurity risk, skill gap, sustainability, and system integration challenges. Overall, the 3 talks show that modern engineering is becoming more complex and connected. Talk 4 focus on aviation and aerospace, especially digital twins, agentic AI, advanced manufacturing, supply chain readiness, and sustainability. Talk 5 focus on automotive engineering and explain how engineers make a real-world decision by balancing time, function, cost, and safety and customer need. Talk 6 focus on automation engineering careers, where engineers need to adjust to adapt to artificial intelligence, robotic, IoT, cybersecurity, and system intelligence. The common message from all these 3 talks is that future engineers must be technically strong, adaptable, responsible, and able to solve problems practically.
So next, I will continue with aviation industry or aerospace manufacturing. For top 4, the topic was related to the aviation and aerospace industry, especially aerostructure manufacturing and future industry development. One key point learned is that the aerospace industry is moving towards digital transformation. Technologies such as digital twins, agentic AI, and digital twin are becoming important in aircraft design. Manufacturing and maintenance. Digital twin can help engineers perform visual testing and predict system behavior, while agentic AI can support planning and decision-making in complex engineering process. Another important point is that aerospace field has strict safety, quality, and certification requirements. Engineers in industry must follow proper standards because even small errors can affect aircraft performance and passenger safety. The talk also highlighted future challenges such as supply chain reliability, material availability, advanced manufacturing, and the need to achieve net zero targets. The aerospace industry is expected to move towards more suitable aircraft design and digital manufacturing system. From this talk, the main insight gained is that aerospace engineer must combine engineering fundamental with a new digital skill. For career development, this means future engineers should be ready to learn simulation, AI, materials, quality management, and system engineering.
Hi, my name is Lara Matthews and I will be presenting slide 5 and 6. So for top 5, the topic was perfect does not exist, how engineers make real-world decisions by Proton. The main lesson from this talk is that engineers do not always design a perfect product. In real industry, engineers must make decisions by balancing time, function, aesthetic, cost, and safety, and customer needs. One important concept is the golden triangle. It shows that every product strategy involves trade-off. For example, a product may have a good function and appearance, but it may require more time and budget. Because of this, engineers must choose the best balance based on market demand and customer expectations. The talk also explained that the highest specification is not always the best solution. A successful vehicle is one that meets customer usage, market demand, and cost objectives. This teaches us that practical optimization is more important than chasing perfection. Another important insight is that automotive engineering requires validation, compliance, and safety testing. Engineers must follow regulations because compliance protects users from dangerous shortcuts. For talk 6, the topic was critical challenges in automation engineering careers. The talk explained that automation engineering is changing very fast because of artificial intelligence, robotics, and Internet of Things, IoT. Because of this, engineers must continuously improve their skills and adapt to new tools and platforms. Another important issue is skill gaps. Automation engineers need knowledge in mechanical systems, electrical systems, programming, system integration, and project management. This shows that automation engineering requires multidisciplinary knowledge. The talk also highlighted integration complexity. In industry, new automation systems often need to work with old machines or legacy infrastructures. If the integration is not managed properly, it can cause downtime, high cost, and implementation errors. Cybersecurity is also a major concern because automated and connected systems can be exposed to cyber attacks. Therefore, engineers must balance innovation with safety and security. The most important career lesson from this talk is communication. Automation engineers must know their product, understand how systems work, communicate with people, and manage problems responsibly.
Next, knowledge and insight gained. From 3 talks, we gained several important insights about engineering. First, technical knowledge must continue to evolve. Engineering fundamentals are still important, but future engineers must also learn new technologies such as AI, digital twins, automation, simulations, data, and cybersecurity. Second, engineering decisions making must be practical. Engineers often work with limited time, budget, and resource. Therefore, they must be able to balance performance, safety, cost, quality, and customer. Third, safety and compliance are a part of professional responsibility. Engineer must not only design systems that work, but also systems that are safe, reliable, and suitable for society. Next, the current engineering issue discussed in the talk include integrations, complexity, skills scarcity, cybersecurity risk, over-engineering, sustainability, and supply chain challenge. Integration complexity happens when new digital systems need to work together with existing machines, aircraft, vehicle, or production system. Skill scarcity is also a major issue because industry now needs hybrid engineers who understand both traditional engineering and digital tools. Cybersecurity risk is important because modern engineering systems are connected through automation, IoT, digital manufacturing. Another issue is over-engineering from the automotive talk. We learned that chasing perfections can waste resource. Sometimes, a reliable and practical solution is better than a perfect but expensive solution. Are very relevant to our future career development. After future engineers, we need to build strong technical knowledge and also develop digital skills. We should learn about simulations, AI, automation system, integration, and validation. We also need to make responsible decisions. This means we must consider safety, compliance, cost, time, quality, and the impact of our work society. Besides technical skills, soft skills are also important. Engineer must be able to communicate clearly, work in teams, manage risks, and explain technical decisions to different people. Overall, this talk reminds us that engineering careers require lifelong learning, adaptability, and professional.
Lastly, in conclusion, Talk 4 showed that aviation and aerospace are moving towards digital twins and agentic AI, advanced manufacturing, and sustainability. Talk 5 showed that automotive engineering requires thread of thinking, validation, compliance, and customer-focused decision-making. Talk 6 showed that automation engineering careers require continuous upskilling, integration knowledge, cybersecurity awareness, and strong communication skill. Our final reflection is that engineering is not only about designing product or system. It is also about solving real-world problems responsibly, making practical decisions, work with people, and continuously improving ourselves. As a future engineer, we must stay adaptable, communicate clearly, thinking critical, and act professionally in every engineering risk. That's all for us. Thank you.